When it comes to systems of equations, so two equations, two variables, there are three ways that we can solve these. We can solve them by graphing. We already know that the solution is going to be the point of intersection, or we can solve them using two algebraic methods called the substitution method or the addition slash elimination method. Okay, so we're first going to look at graphing. I will tell you this, graphing is not the best method if you're doing this by hand. Graphing can be super great if you're using a graphing utility like a graphing calculator or Desmos. But to work this by hand, you got to be really, really careful. Okay. So please do keep that in mind. We will graph this one. We're just going to do one example. We will graph it by hand and then we'll verify our results with Desmos. And then after this, we will always we will always solve using one of the two algebraic methods. Okay. So again, Desmos, phenomenal tool. It is incredible. It can really help you get a deeper learning, a deeper understanding of things. I should say deeper understanding. Learning like that isn't really a word. But anyway, you can get a deeper understanding of what is going on, but you can also overuse Desmos to the point where you're not learning anything and you've become completely reliant on Desmos. And we do not want that to happen. You will absolutely have to solve systems of equations by hand using the two algebraic methods. You can use Desmos to verify results, but your algebra better back up your answer. Okay. So again, we're going to look at three methods: graphing, substitution, and addition or elimination. It just depends on the book which one you're going to call it. Both make sense once you see how it works. All right, so let's talk about graphing. If you were to solve a system by graphing, you would want to graph both equations on the same Cartesian plane. All right. And then you determine where the point where the two lines intersect. And this is really great, again, if you're using a graphing utility. If you're trying to graph this completely freehand, this can be really tricky because as precise as we might think we're graphing, typically when we graph by hand, things are a little wobbly. Okay. So again, I state down here, this is a great method for visually understanding the solution to a system of equations. However, use caution if graphing by hand. This method is best used using a graphing utility, meaning a TI-83, 84, 85, 86, whatever calculator, or Desmos. Okay, so example 2 here says, solve this system by graphing, express the answer as an ordered pair. Okay, the easiest way to graph linear equations in two variables is to graph using slope-intercept form, meaning you solve for y, that automatically gives you the slope of the line and the y-intercept, and then we can use the y-intercept and the slope to graph. Okay, so the system that we need to solve is 2x plus 3y is 6, and 2x plus y is -2. Okay, so what ordered pair satisfies both of these? All right, first thing I'm going to do is I'm going to rewrite my system using, by rewriting the equations in slope-intercept form. So I'm going to rewrite the system using slope-intercept form. So let me get my little glove on so I don't rest too weird on my little screen. Hold on. All right, so we have 2x plus 3y equals 6. I want to solve this for y. So I need to isolate the 3y, which means I need to move the 2x. I do that with subtraction. On the left, the 2x's cancel because 2x minus 2x is 0. That leaves me with 0 plus 3y, which is just 3y. And then on the left, again, humor me, put the x term first, the constant term second. That's just the format that we would write a linear equation in. So we would get -2x plus 6. We need to isolate the y, which means we need to undo the multiplication of 3 and y. So to do that, I divide, and I don't just divide the y term, I divide all of the terms by 3. On the left, 3 divided by itself is y. So 3 divided by itself is 1. 1 times y is what I should say. And then -2/3 x is just -2/3 x. And then 6 divided by 3 is 2. So that is my first equation. All right. And then the second equation, I have 2x plus y equals -2. Again, I want to solve it for y. I need to isolate the y term. To start that process, that is going to require me to move the 2x with subtraction. So I subtract 2x from both sides. On the left, 2x minus 2x is 0. 0 plus y is y. And then on the right, we just get -2x minus 2. So those are my two equations. So an equivalent system would be y equals -2/3 x plus 2, and y equals -2x minus 2. Okay, now remember, when you solve an equation for y, the whole point in doing this is you get the slope and the y-intercept for free. So looking at the first equation, I would say my slope is -2/3. Whoops, I was about to rewrite the equation. My slope is -2/3, and my y-intercept is just 2. Looking at the second equation, my slope is -2, so I could treat that as -2/1 so that I have a distinct rise and a distinct run. And then my y-intercept here is -2. So let's graph these two equations. I'm going to do one in red and one in this blue color. Okay? So let's look at the first equation. We always have to have a point on the line. That's our y-intercept. So I need to plot the point 2, well, the y-intercept 2, which is really the ordered pair 0, 2. So at the origin, I don't go left or right, but I do go up 2. I don't know why it just made a heart. So we go up 2, okay? And then from there, I apply my slope. Well, my slope is -2/3, so I'm going to put the negative in the numerator. That tells me to go down 2 and to the right 3. So I go down 1, 2, and to the right 1, 2, 3. Go down 2, to the right 1, 2, 3. Remember, we could reverse that. Instead of going down 2, we could go up 2. But if we go up 2, we have to go to the left 3. Okay? So I could go up 2 and then to the left 3. And I have yet another point on the line. So we connect. Hopefully we're doing this accurately enough, but can you kind of see what I mean? When you graph by hand, it's a little wobbly. It's not super accurate. Okay? Now for the second line, we'll do it in this bright blue color. Our y-intercept was -2. So at the origin, I do not go left or right. I just go down 2 because remember, this is really the ordered pair 0, -2. So that would be right here. And then my slope is -2, but remember, we need a rise and a run. So we always write our slope as a fraction when we're graphing, so we can just plop it over 1. So if I put my negative in the numerator, that tells me to go down and to the right. So I could go down 1 to the, well, I could go down 2 to the right 1, down 2 to the right 1. Or I could flip it. I could go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. All right. So we graph, we connect, we use our arrows, and it looks like the point, the two lines do intersect at a point, and it looks like that point is right here. Now, assuming I graph this accurately enough, we would say our ordered pair is, let's see, we would go to the left 1, 2, 3, and then up 1, 2, 3, 4. We would say our ordered pair solution is -3, 4. But let's use Desmos to verify. Okay, let me take a picture again because I don't have the actual worksheet in front of me. All right, so let's verify this with Desmos. All right, now the cool thing about Desmos is you don't really have to solve the equations for y. If you want a table of values, you do, but just to graph the equations, you can leave them in standard form. So let's see, where is Desmos? Right here. So Desmos, let's clear out the old junk. All right, you can also just like refresh your screen and start over, but I usually just click those X's. All right, the first equation was 2x plus 3y equals 6. The second equation was 2x plus y equals -2. All right, and we can see that our ordered pair solution is -3, 4. So our graph was accurate enough that we were able to pinpoint the right ordered pair. Now, just to prove a point to you, if you wanted to, you could graph the equations in slope-intercept form. So we had y equals -2 divided by 3, x, I don't remember what it was. Hold on. My phone, okay. We had y equals -2/3 x plus 2. And then we had y equals -2x minus 2. And we can see here that even though we graphed the different format, they're really the same exact equations and they have the same solution. Okay, so it doesn't matter here if you graph the slope-intercept form version or the standard form version, they're the same equations, you're going to get the same solution. Okay, so that is graphing systems of equations to determine their solution. It is a perfectly legitimate way to do this. It is definitely best done with some kind of technology. Doing it by hand, graph paper is going to make it better, but still a little wobbly. All right. So graphing is a good way to check your answers when you do the algebraic methods. Okay. So in the next two videos, we will look at the algebraic methods for solving systems.